Good morning to all you fabulous fives out there. Lovely to have you with me this morning. I hope your times table challenge is going well. I know that I keep going on and on and on about times tables and mental maths, but they really are the basis of a good maths mark. Being able to do that makes all the other things easier. So please practice. And I will set a challenge for you. I'm going to do my 8 times table. I'll time it and we'll see what it is, and then hopefully you guys can aim to beat it. I won't go as fast as I can. I will try and be clear, but let's start. I'll use my phone to time. So 8, 16, 24, 32, 40, 48, 56, 64, 72, 80, 88, 96. Right, 8 seconds, that's the challenge. See if you can do it quicker than that. And now on to our lesson. A reminder that if you have any questions about maths, you want to share with me what your times table challenge times are, anything like that, you want to say hi, grade5@worksheetcloud.com, email me, and then after the lesson, click on the link above, do the worksheet just to check that you've understood what it is that we're covering in today's lesson. I'm Mr. Travis. Today we're looking at factors, multiples, primes, and composites. I'm sure that you've heard all of those words. Perhaps maybe prime and composite numbers would mean you would have heard it as prime numbers and composite numbers. But primes and composites, I'm sure you've heard all those things. It's really just a reminder and maybe some practical work with them and how to find primes. Lesson goals today. Know what factors and multiples are, be able to find factors of a number when I give it to you, be able to identify prime numbers and composite numbers. So to do that, you need to know what they are. Drag my video out of the way quickly. So let's look on the left at multiples. Multiples are numbers in the times table of something. So when I say we're looking for multiples of 6, it means anything in the 6 times table. So 6, 12, 18, 24, and so on and so forth. There are many multiples of any number. So even if I give you a really big number like 5,000, there's still multiples of 5,000. So 10,000, 15,000, and so on. So all numbers have multiples. Some of them are just really big. But it's important to know that there are many multiples of every single number. You might be asked about multiples. You might be asked something like, is 72 a multiple of 6? And that's really asking, is 72 in the 6 times table? Anyone? 6, 12, 18, 24, 30, 36, 42, 48, 54, 60, 66, 72. Yes, it is. It's 12. So 6 is a multiple. 72 is a multiple of 6. Or you might be asked to write down a multiple of 7. That is an even number. So it's got to first of all be in the 7 times table, but it also needs to be an even number. So remember, even numbers are numbers that end on 0, 2, 4, 6, or 8. Okay, so 7 wouldn't work because it's an odd number. 14 would work. So 14 is a multiple of 7 and it's an even number. So it's 28. There are lots of them. It's every second one in the 7 times table would fit that definition. You might also be asked to write down something that's a multiple of 2 different times tables. This is useful for when we were doing fractions and we needed to find a common denominator. We needed to find something that 2 numbers fitted into. That's what we were doing. We were finding a common multiple, the lowest common multiple. So we're looking for a number that's in the 6 and 7 times table. The first one that I can think of is 42, which is 6 times 7. So it's in the 6 times table. It's a multiple of 6. It's in the 7 times table. It's a multiple of 7. So that's multiples, right? So I like to think of multiples are, okay, we'll come back to that. Multiples are made up of a particular number. So multiples of 6 are numbers that are made up with 6. Factors. Factors are whole numbers that fit into something exactly. So numbers that have the number you're looking at in their times table. So it's really the other way around. So when I say what are the factors of 6, I'm trying to find all of the numbers that fit into 6 exactly. In other words, in this case, with 6, it's 1, 2, 3, and 6. Because 1, 2, 3, 4, 5, 6, 1 fits into 6, 2, 4, 6, 2 fits into 6, 3, 6, 3 fits into 6, 4, 8, nope, 4 is not a factor, 5, 10, 5 doesn't fit into 6, so it's not a factor, and 6 fits into 6 once, so 6 is a factor. So those 4 numbers are all the factors of 6. Some numbers have only 2 factors, some numbers have many factors. We'll look at finding out what factors of a number are shortly. Ways you may be asked about factors: you might be asked to list the factors of 10, for example, and you have to find all the numbers that fit exactly into 10. We're going to practice that. You might be asked, is 5 a factor of 14? So asking if 5 fits exactly into 14. Nope. You might be asked, how many factors does 24 have? So then you'd have to work out how many there were and count them. So if I was asked, how many factors does 6 have? Then the answer would be 4, because 4 separate numbers fit exactly into 6. So that's multiples and factors. And when I think of factors, I think of F as find what fits into it. So multiples make up, factors fit in. Multiples M make up, factors fit in F. That's how I remember it. If you remember it that way, that's great. If you remember it some other way, as long as you remember it, that's really what's important. We can find factors in different ways, and I'm going to show you 3 different ways. I really don't mind which one you choose to use. In the end, it's really about whether you can find all the factors that you're looking for. So I'm going to start off by looking to see what the factors of, let's start with 12. Right, so I could do this. The first way I'm going to show you is just using your head. So you could say, well, okay, well, first off, 1 fits in to every single number. So we know that 1 is going to be a factor of any number. So 1 fits in. Does 2 fit in? Let me check. 2, 4, 6, 8, 10, 12. Yes, 2 fits in. Does 3 fit in? 3, 6, 9, 12. Yes, 3 fits in. Does 4 fit in? 4, 8, 12. Yes, 4 fits in. Does 5 fit in? 5, 10, 15. No. Does 6 fit in? 6, 12. Yes. Does 7 fit in? 7, 14. No. Does 8? 8, 16. No. Does 9? 9, 18. No. 10? No. 11? No. 12? Yes. 12 fits in once. And there we go. That's a list of all the factors of 12 just as they are. So you can do it that way. That's one potential way to write it, to do it. Yeah, I'll come back to that note that I was going to share with you now. All right, another way to do it is what I think of as a factor rainbow. I'm going to do the same problem. I'm looking for factors of 12, and I'm going to use the rainbow method. It's not my favorite method, and I'll explain why afterwards. But here we go. I'm going to start off with 1, because 1 fits into all things. Ooh. And then what I'm going to do is I'm going to say to myself, what will I times by 1 to get 12? 1 times 12. So I've got 2 of my factors written down. Next up, I'm going to ask, what's the next small number that fits in? Well, 2 fitted in. And 2 times what would give me 12? 2 times 6. So there's my next pair. Three fitted in. 3 times what gave me 12? 3 times 4 gave me 12. And that is actually all of them. So then afterwards I would write it underneath. 12 has 1, 2, 1, 2, 3, 4, 6, 12. And there we go. You've got the same answer there as you do there. This is nice because factors are in pairs. They always come in pairs. And so it's quite nice to draw it as a rainbow. The drawback of a rainbow is, and it won't look like this with mine because I've used different colors, But sometimes if you're using the same color or a pencil, it all kind of blends together, and you can't always tell if this is 126 or 1 and 2 and 6 or 64. So it gets a little bit messy, and so this isn't my favorite method. My favorite method, which I'm going to do with the same one, I call factor trees. And in factor trees, I have branches, and those branches come in pairs. So again, using the idea that factors are always in pairs, like the rainbow, I always start by doing this branch, 1 and itself. So we know that 1 fits into anything, and anything times by 1 is itself. So we know that the first pair will always be 1 and whatever number is in the trunk of the tree. Next up, I'm going to draw my next branch. I'm going to see what fits in next. Well, 2, and 2 times what gives me 12? 2 times 6. 3 fits in. 3 times what gives me 12? 3 times 4. The next number that would fit in would be 6, and it would be 6 times 2. But we already have 6 times 2. So we've gone all the way. We don't need to do any more. We just need to list them underneath. 12, 1, 2, 3, 4, 6, and 12. Right, and when we're writing that down, we're looking at the first branch for each. So 1, 2, 3, 4, 6, 12. 1, 2, 3, 4, 6, 12. So there's our factor tree, and this is the one I like the best. It's a very easy way of doing it, and for me, it makes it the easiest not to miss any of the factors. So factor trees, they come in pairs. We see how many branches each one has. So as I say, I don't mind which method you use to work it out. I'm going to use the factor trees because those are my favorite, the one I've seen children have the most success with. I hope you have a pencil and paper or pen and paper with you. I'm going to give you a few now for us to work out. So let's start off with this one. So I will put down a few. You guys get going with them, and then after a little while I'll come back to them and I'll go through them with you. Right, I'm going to go through the first three, even if you haven't done them. If you'd like more time to try it on your own, that's okay. But this is a new process for some of you. So let's do this. Right. I know that 1 fits into everything and 1 times itself. Does anything else fit into 2? Well, we've covered it. So the answer to the factors of 2 is 1 and 2. Or 1 and 2. See, my internet is being a little bit slow and it's taking a little while to update from my iPad. There we go. Right, let's look at the second tree. I always start with 1. 1 times what gives me 3? 1 times 3. Does anything else fit into 3? 2, 4? Nope. And so that is the answer to 3. 3 has 1 and 3. I did say that there were some that only had 2 factors and some that had many. Let's have a look at 8. Well, the first number that we always start with is 1. And they come in pairs. 1 times itself. 1 times 8 is 8. Let's see. Does 2 go into 8? 2, 4, 6, 8. Yes, it does. So we've got 2. And 2 times what gives me 8? 2 times 4 gives me 8. Does 3 fit in? 3, 6, 9. No. Does 4? Oh, we've got 4. So that now is all of them. So 8 has the factors 1, 2, 4, and 8. Let's move our screen over and let's try number 9. If you'd like to try some on your own, just pause the video. So I'm going to start again, as I always do, with 1 and myself, or 1 and itself. 1 times 9 is 9. Does 2 fit in? 2, 4, 6. Nope. Oh, 2, 4, 6, 8, 10. Nope. Does 3, 3, 6, 9. Yes, 3 fits in. How many times does 3 fit in? 3 times 3. 4, 8, 12. No. 5, 10. No. Okay, and that's all. So our answer to the factors is 1, 3. We don't list a 3 a second time because we've listed it already. So it's 1, 3, and 9. It's like, yeah, putting the same thing twice. It's still not going to make more factors. It's the same factor, so it's just a repeat. So we only put that down once. Let's have a look at 10. Always start with 1 and myself. So those are the factors. Does 2 fit in? 2, 4, 6, 8, 10. Yes, it does. 2 times 5. Does 3 fit in? Nope. Does 4 fit in? Nope. 5. 5, yes, but we've got 5 already. So factors of 10, 1, 2, 5, and 10. We're going to do one more and then have a quick look back at what we've done so far. Always start with 1 and myself, or 1 and the number in the tree trunk. Does 2, 2, 4, 6? No. Does 3, 3, 6? No. Does 4, 4, 8? No. Does 5? Yes, we've got 5. So that's all. This is another one of the ones that only has 2 factors. Right, if we look at the ones we've done so far, you will notice that every single one that we've covered so far, whether it's got 2 factors or more factors, always has 1 and itself, 1 and itself, 1 and itself. All right, so every single number has at least 2 factors, and those factors are 1 and itself. Got some more for you to try. We're moving on to slightly bigger numbers. And remember yesterday, or in the previous lesson, when we looked at the divisibility rules, this is where the divisibility rules will come in handy, because you can always check to see what's going to go into the number. So we've done 12 quite a bit, so let's do 16. Here are a couple for you to get going with. I'll give you a little while to get started, and if you need longer, you can pause it. Right, grade 5s, I do want to still come back, or I do want to get onto prime and composite numbers, which shouldn't take too long. But because of that, I'm not going to leave it any longer. We're just doing 10 of these. If you'd like more time, and I think it'd be great if you paused the video and did them yourselves, so you could check that you're on the right track before you get to the homework. It's always useful to first do it, or first try it, before you have a look at how somebody else does it. It's useful to watch somebody else too. That's how we learn as well, but trying is super important. And remember, trying and failing is not a problem as long as you learn from your mistakes. Having a look at 16, I'm going to start with first 1 and itself. That's in everything. Then I'm going to try, let's see, 2, 4, 6, 8, 10, 12, 14, 16. 2 goes in. 2 goes in 8 times. 3 doesn't go in. 4 does go in. This is why times tables are so important, because you can see what goes in. So 4 goes in, 4 times 4, and that's going to be as many as you get. There won't be any other ones that fit into there. So my factors written out neatly underneath, factors of 16 are 1, 2, 4, 8, and 16. Factors of 24. Always start with 1 and itself, so 1 and 24. 24 is even, so 2 goes in. 2 times 12. You can count that. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24. 12 times. 3, 3, 6, 9, 12, 15, 18, 21, 24. Yep. 3 goes in. 3 goes in 8 times. That is an 8, even if it's a bit messy. 4 goes in. 4, 8, 12, 16, 20, 24. Yes, 4 goes in 6 times. 8 goes in 3 times, but we already have that one. And so now we've covered all of them. So writing it out neatly underneath, 24 has the factors 1, 2, 3, 4, 6, 8, 12, and 24. So I did say that some have only a few factors and some have many. We're heading into some of the ones that have quite a lot more now. Let's have a look at 36. Always start with 1 and myself, 1 and 36. 36 is even, so 2 goes in. Oh my goodness, that's a lot of 2s. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32, 34, 36. My goodness, how many is that? That was 18. 3, 3, 6, 9, 12. Yes, it does. I'm not going to go all the way, but it does. It's what the advantages of knowing your times tables. 3 times 12. 4 goes in, and this one I am going to jot down something underneath. Well, I know that 4 goes into 40 10 times. So if I'm going backwards 1 to 36, then it would be 9 times. So 4 times 9. It's a little trick for working out if it's close to the 10 times of something. 5 doesn't go in. 6 does go in. See, I know that 5 doesn't go in because that ends on a 6, and 5s only go into numbers that end on 5 or 0. So that's one of the tricks that I'm using. Remember the divisibility rules from yesterday? Teachers teach things in a logical way that makes sense because we use things to do other things. So 6 goes in here 6 times, and that is the end of it. So writing them out neatly, and you can see when I do this, I'm going across the branches on the one side, and then I'm coming back on the other side. So it's 1, 2, 3, 4, 6. I'm only going to write down one of them because otherwise it's repeating. 9, 12, 18, and 36. That is a lot of factors. One more to go. Let's pick purple for this one. Right, 1 in itself. Ends on an 8, so 2 definitely goes in. 2 goes into, well, 2 goes into there. 4 times 2 goes into there, so it's 24. 3, well, let's see if we add those together, we get 12. So that means 3 does go in. So 3 goes in how many times? 3 goes in 16 times. You can count there. We'll do division in a future lesson, which will help you with this as well. Does 4 go in? Yes, 4 goes in. 4 goes in there 12 times because 4, 8, 12, 16, 20, 24, 28, 32, 36, 40, 44, 48, 12 times. Does 5 go in? No, because it ends on a 8. Does 6 go in? Well, if you add those together, it's 12 and 12, and it ends on an even number, divisibility rule for 6. If you don't remember the divisibility rules, I think it's best to go back and learn them. And if you missed the last lesson, I really think it's an important one. Although it doesn't always seem that way, it's very, very useful. It's like a little tool in your tool chest that helps you go quicker. So 6 goes into there 8 times, 7 doesn't, 8 does, but we've got 8, and so that's it. So 48 has the most factors we've seen yet. 1, 2, 3, 4, 6, 8, 12, 16, 24, and 48. We have just time to look at prime numbers and composites. Prime numbers. So remember we pointed out that a couple of them only had one pair of factors or two factors. Those are prime numbers. So if there are only two numbers that fit in exactly, it's going to be 1 in itself. And I have a little rhyme, and this is probably the closest you're going to get me to singing on a platform like this. Or, yeah, I definitely wasn't on Idols because I know I can't sing. But if my factors are 1 in myself, then I sit on the prime number shelf. That's a little rhyme that I use to remember which are prime numbers. So when I say sit on the prime number shelf, I mean that I'm a prime number. So if my factors are 1 in myself, then I sit on the prime number shelf. Let's look at our whiteboard again and look to see which of those numbers is prime. Well, if we look at the first one, the only things that fit in are 1 in itself. So 2 is a prime number. I'm just going to put a P next to it. P. If I look at the next one, the only things that fit in there are 1 in itself. So 3 is a prime number. If I look at this one, 8 has 1 in itself and some other things, so this is not prime. 9 has 1, 3, and 9. It's got more than just itself and 1, so that's not prime. 10, not prime. So 5 only has 1 and 5, so 5 is also a prime number. The other ones we've done have lots of factors, and so those are not prime. So if my factors are 1 in myself, then I sit on the prime number shelf. Out of interest, 2 is the only even prime number. Every other prime number is an odd number, and the reason for that is that 2 fits into all the other prime numbers. So whatever the other prime number is, it will have 1 and itself and at least 2 and 2's partner. So anything that's even above 2 will definitely not be a prime. So once you see it's even and bigger than 2, you don't even have to check further than that, you know it's not prime. And there's one more word to look at. Composite numbers. And this is going to be really hard to remember. A composite number is anything that's not prime. So all the ones that weren't prime on our whiteboard are composite numbers. So let's have a look. This one is a composite number. A composite number. Composite. 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 And composite. So it's prime and composite is a way of dividing numbers. If your factors are 1 in yourself, then it's just prime. And if it's composite, or if it has more than just the 2 factors, then it's composite. That's where we're going to end today. We know what prime numbers are. We know what composite numbers are. We've explored what multiples are. We've explored what factors are. You needed to know what factors were in order to be able to understand prime numbers. After the lesson, click on the link above and do the worksheet to check that you've got this. Also, if you have any questions, email me grade5@WorksheetCloud.com. And I've been waiting the whole lesson to do this. My name is Optimus Prime. Autobots, move out. Have a great weekend, grade 5s.